Okay, when we estimate a population variance, our assumption are going to be the sample is a simple random sample. That's the same assumption from before. The population must have normally distributed values. So this is a much stricter requirement. Remember, for the mean, we looked at either a sample size large enough or a normal population. In order to estimate the population variance or the population standard deviation, we must start with a normal population. So it says even if the sample is large. We are going to look at the chi-square distribution, which is a right-skewed distribution. Looking at standard deviations, we need something that describes this distribution of standard deviations. What is a couple characteristics about standard deviations? Standard deviations are numbers that are always what? Always positive, or sometimes they could be, what's the lowest it can be? If there's no variation within our data set, then our standard deviation is 0. So it's 0 or a positive number. In general, it's a positive number. So we don't have the symmetry, with the positive and the negative numbers with the chi-square. They're all positive values. That makes it a little more complicated. We actually don't have a calculator shortcut. So this is one we have to manually calculate. We also have to actually find two different values. So we're going to find the left chi-square value and the right chi-square value. And then one other difference is that when you're looking at your chi-square table, it says the area to the right. So z-scores are area to the left. T-distribution, we have either the area in one or two tails given. And now the chi-square uses area to the right. Now why is that? I don't know. Maybe just to confuse you. So you have to look at your table. It's going to tell you exactly how you find these. And we will actually label them for Chapter 7, where you can simply say, hey, these are the two columns that go together. I want 95% confidence. Therefore, I'm going to find my two values. So let's look at how this works. The degrees of freedom have the same definition. So degrees of freedom is equal to n minus 1 again. We're going to find the critical values for a 95% degree of confidence, sample size of 10, 20, and 30. Degrees of freedom for a sample size of 10 is 9. Degrees of freedom for a sample size of 20. And then the last one is 29. Okay, so we will find both a left and a right chi-square value. So I'm going to draw over here, I'm going to draw it as a right skewed distribution. So it's not symmetric like the normal and the t. It also starts at 0 over here. So I'm going to have two values. 95% means what's the area in the middle? 0.95. So we still have that given. We still have 5% in the two tails, which means what percentage in each tail? .025 and 0.025 over here. Okay, so we are going to start with our right chi-square value. And the chi is a Greek letter. It looks kind of like an X. And it is also a squared value. So since we're finding area to the right, our area over here is what? So our right chi-square value has what area to the right? Okay, 0.025. Okay, so let's see where we find that on the table. So it says area to the right and 0.025. That is right here, this column. And we now go to 9 degrees of freedom, and that number is 19.023. Okay, then we go down to 19, which is 32.852, and then the last one at 29 is 45.722. Okay, so let's write these three chi-square values, and I'm down. So the first one was 19.023. The second one was 32.852. And the third one was 45.722. So that's the right one, which is a lot easier to find because we already labeled it to have that area of 0.025 on the right. Okay, how about the left chi-square value? What area does that one have to the right? So the left one being right here. Right, so I have to take the middle and add the green tail to it. So the left chi-square value has an area of 0.975. Okay, so what column does that correspond to? It's the third column. So go down to 9 degrees of freedom and write down your left chi-square value, which is how much?
2.7.
So that's the left one. So find all three of those.